Thank you very much. Our third and final presenter will be Dr. Howard Maccabe. Dr. Maccabe earned a PhD and an MD in the biophysics group at the University of California, Berkeley in 1966, and his MD at Miami in 1975. His postgraduate residency was at UCSF in radiation oncology, and he was medical director of the Radiation Center. No problem. In Walnut Creek, California, from 1980 to 2005. He is on the clinical faculty of UCSF and Stanford University Medical School. He spoke at the first Earth Day in 1970 on environmental benefits of nuclear power. He's been studying the potential health effects of various predicted environmental disasters for 3 decades. His current research is on health effects of climate change. He is the author of the article on this in the forthcoming Encyclopedia of Global Warming. And we will welcome Dr. Howard Maccabe.
I can't read that without looking very closely.
Update on climate change and health in 2008? No.
This one right here.
International Conference on Climate Change.
Right. Thank you very much. How much time do I have? 20 minutes. Okay. Last year we had about 20 people at the session, so I made 20 handouts. We have about 40 now. For those of you who didn't get a copy of the graphs or the abstract or summary and the references, I have 20 more copies. In fact, I'll ask somebody to distribute them now, just a second. It's that pile right on top of my briefcase in the second row. Thank you. Correction from last year's bio, I was not the president of DDP last year. I was the founding president in 1982. I am currently a director of DDP, and there are several of our members here. And yesterday night there was an appeal for people that want to join organizations of scientists and physicians who are protesting some of the baloney that's going on in the environmentalist movement right now. I claim it's a problem of environmental illness. Anyway, DDP is having its annual meeting this summer in Colorado, in Denver. I think it's the first week of August. If you're interested, see me afterwards. Or Jeremy, is Jeremy in the audience? Or Jane Orient, is Jane here? Well, I guess they're not here. Anyway, see me afterwards and I'll get you the information on the meeting. Some of this material will be discussed in more detail at that meeting. Also, Art Robinson, who's one of our distinguished keynote speakers at the conference, will be giving his annual wonderful presentation. I have some prejudices about this issue, which I will reveal as we go on. My first experience with the health effects of global climate change or local climate change came when I was an intern at San Francisco General Hospital, July through December of a long time ago. In July, I was a pediatric intern, and we had no deaths from heat in my entire 2 months on the pediatric ward. In December, I was in the emergency room, and I had 7, 8, 9, and 10 admissions per night, of which half a dozen were due to the effects of the winter on our patients in the streets of San Francisco. So I knew viscerally that cold is much more dangerous to health than heat, at least from summertime in San Francisco. Of course, that is sort of a non sequitur. And I have to thank Al Gore as part of my acknowledgments for getting me interested in this issue. When I saw his movie, An Inconvenient Truth, several years ago, it made me so angry because there were no truths in the movie from my own personal experience that I started doing intensive research on this question. So thanks, Al Gore. Let's see now. Last year, if you were here, and many of you were, I talked about the potential health benefits of global warming, and at that time I looked at the data from around the world on health effects of warming. And I concluded from looking at all of the data that I could find, and I thank the previous speakers because both of them alluded to some of that data, that there was actually an expected direct health benefit from the kind of warming that is predicted by the IPCC. The climate is continuing to change, as it always does, and as you know, the most recent temperature measurements, or the calculations of average global surface temperature, have now showed no warming for the past 2 years. In fact, some significantly measurable cooling on the average. And of course, all of you know that averages don't tell the whole story. There's much more of the story in the fluctuations of the temperature than in the average temperature, as the previous speakers have explained. And we all know that from personal experience on a daily basis. Nevertheless, the debate is on the global temperature, so I'll use some of those numbers in my discussion. Anyway, so what are the consequences for health of the changing climate, including the current 1 or 2 year trend of a cooling nature? And those of you who attended the paleoclimatology session this morning heard very convincing arguments that the trend is turning over toward cooling due to multi-decadal oscillations, and I can't explain that because I don't understand it yet, but I understand a piece of it, which I'll try to explain to you. Next slide, please. Is there a light pointer? Hit the space bar? Oh, you mean there's a mouse? Oh, thank you so much. That's space bar. Okay, a little bit of humor. This is a picture of hundreds attending a global warming protest. Okay. This is one presentation of the way the temperature data is going. This was just published a couple of months ago by Lord Monckton in his SPPI publication online. The reference is in my list of references, which you all should have access to. This is the actual world average surface temperature data from non-controversial authorities. This is the extrapolation of the IPCC predictions. This is what they call the central projection. This is their low estimate. This is their high estimate. It's obvious that after only 10 years, the IPCC projections are grossly wrong, not even statistically within fluctuations able to describe what's actually happening. This is the cooling of the past year, and it's the data tends to show a further downtrend in the past 6 months or so. Whoops. How do I backspace? Can I go back one? The up arrow? Try the down arrow. Well, we'll just stick with this one. The question of climate change is not new. Al Gore and James Hansen didn't invent it. It's been important for all of our scientific, in fact, all of our biographical lifetimes. This is a book that was written in, well, I'm sorry, I need to go back. That's all forward. Okay, that's it. Thank you. This is a book that was published in 1976 by Lowell Ponty, a well-known news commentator and sort of rambling intellectual from Southern California. You see the title, here's the subtitle, Has the Next Ice Age Already Begun, and Can We Survive It? This is a very good book and I recommend it. Unfortunately, it's out of print, but here's a copy if you want to look at it yourself later. At this point, Ponty was reporting on a widespread scientific consensus, an actual consensus of scientists and climatologists in the late 60s and 70s and, well, the late 60s and the 70s, that there was a cooling tendency, and you've seen that on some of the graphs of historical climate change. This is a book that was published by famous astrophysicist or astronomer Fred Hoyle in 1981. Fred was a little late with his publication because '79 is what has been accepted as the end of the severe cooling period and the turnover into the panic about possible warming. But he calls cooling the ultimate human catastrophe. This is a graph in Hoyle's book. Whoops. Let's see now. Where he talks about global climate over 65 million years, which I haven't really looked at in terms of human health effects because humans weren't on the scene. Hoyle makes a very interesting point, though, that ice ages, in some senses, have been beneficial to man, because what Hoyle says that the last ice age destroyed all of our competition for the dominant species on the Earth, especially the dinosaurs, et cetera. And after the ice age, human beings emerged as the dominant species. An even more controversial speculation, though, is that human beings existed before the last ice age ended about 10,000 years ago, and why weren't they the dominant species? And Hoyle makes the argument, I guess, that we needed the ice age to destroy the competition. This is a more recent book, and this is my favorite book on the causes of climate change. This is called The Chilling Stars by Henrik Svensmark, who with his colleague Friis Christensen in Denmark have propounded the theory of what you might call the chilling stars, that it's cosmic rays coming from exploding stars all over the universe coming into the solar system, which cause ionization as they go through the atmosphere, which causes condensation of water vapor into clouds. And the more ionization from cosmic rays there is, the more clouds and the cooler it gets. The major factor that modulates this is the sun's magnetic field, which bends charged particles, heavy charged particles, out of the solar system and protects us from the massive cooling that occurs when there is significant increases in cloud structure. That reveals my prejudice. My PhD thesis was on the physical properties, especially ionization, of heavy charged particles, such as cosmic rays. I did it because I was trying to work on developing new particle beams to treat tumors with, but it also, the theory and the experiment work exactly with respect to explaining the behavior of cosmic rays going through the atmosphere. This is an example of a graph which shows a graphic correlation between the sun's magnetic activity versus the cosmic ray flux, which causes more clouds, which causes colder climate. This is a correlation between the time, 12,000 years ago until the present, of the state of the sun, whether it's quiet or whether it's intense. Actually, in this particular representation, when the cosmic rays are strong, that means a weak sun with weak solar magnetic fields that causes cooling. And this is their correlation, and it's a fairly good correlation that seems to explain most of the major climate changes for the past 12,000 years since the Ice Age in terms of fluctuations of these solar magnetic fields. In order to scare you, this is a photograph by an accepted, non-controversial scientific institution of the surface of the sun as of September the 27th, 2008, in which there were no sunspots whatsoever visible. This is the quietest the sun has been in 50 years. And as I just showed you, there's a strong correlation between quiet suns, lower solar magnetic fields, more cosmic rays, more clouds, and colder weather. Sorry, colder climate. This is a bar graph comparing the days in which there are no sunspots as a function of some time periods in the past. This is a comparison, and as of September the 27th, they were already at 200 days without sunspots, and the number was still rising because this was not the end of the year. A linear extrapolation would get us up to about 300. I don't know what the actual number was. If somebody has that, I'd be glad to hear it and change my talk. So in terms, if you believe that the sun and its magnetic fields affect our climate, we're in for some more cold years. Fred Hoyle was a very brilliant man, and he shows this graph. This is his explanation of what causes the weather to change in the climate. This is the average temperature in his data, again from 28 years ago. And he shows a correlation between that and his measurement of the solar effects indirectly affected by the magnetic field. And there's a fairly good correlation by Hoyle, again, 28 years ahead of Svensmark and Christensen. It's not exact, and he theorizes that it's a thing called the Milankovitch effect. Milankovitch was a Russian physicist who, Serbian, please excuse me, you're exactly right. A Serbian physicist who believed that these fluctuations are caused by fluctuations of the sun's orbit and its wobble around its orbit isocenter. And I haven't looked into Milankovitch yet. That doesn't contradict Svensmark and Fries Christensen, because they just talk about the magnetic fluctuations. They don't speculate about the cause of it, and Hoyle does. Anyway, now we're leaving climatology and paleoclimatology and going to health effects. This is perhaps the best data set on European climate. It was already referred to by my colleagues, Dr. Schwartz, and I think not by Dunn. This is the original data that was published by the Euro-Winter Group with Keating, who was previously referred to as the head author, and it shows a temperature trend. This is the data on IHD, which stands for ischemic heart disease, CVD, cerebrovascular disease, that's strokes, RD is respiratory disease. These are the data dots as a function of temperature from minus 20 centigrade to 20 centigrade for 2 areas. At the top, which fell off the screen, I believe, is Athens, Greece, for these 4 graphs. And this is Finland. So Athens, Greece represents the southern part of Europe. Finland represents the most northern part of Europe. And the data all, if you draw straight lines, and I didn't draw these straight lines, these were drawn by Keating's group from Europe, a non-controversial, non-prejudiced group of physicians and scientists. Every single one of them shows a major trend with the slope being downward, which means mortality rate, that's the that's the ordinate, daily deaths per million in Athens, Greece, or here it is, Finland on this side. And it shows a significant downward trend, which means, just as Joel and Dunn spoke of, that warming is good for your health. The death rate drops in every case significantly as a function of temperature increasing. That was where I reached at the end of my talk last year. Now I'm concerned about the cooling because of the reasons I've just given you. Up here, as the temperature decreases, you get high death rates. So that's what I'm talking about here. And as you know, cardiac deaths is the #1 cause of death. Strokes isn't #2, it's usually cancer, but it contributes significantly, and respiratory deaths also contribute significantly, and they are much, much higher for elderly people. Of course, the same thing is true of strokes and heart attacks. Let's see what that means for the United States. Oh no, let me just go back 1 point, I think, to London. Sorry, this is another paper by Keating's group. I think this is the data. Oh, this includes Helsinki, London, and Athens. Again, the same trend, decreasing deaths with temperature, increasing deaths with very high death rates, even in Helsinki, Finland, where they should be ready for cold temperatures, with the lowest temperatures. Same thing here, same thing here. This is not the overall population. This is the death rate for people aged 65 through 74. The slope on the other curve was about 2% increased death rate for 1 degree centigrade decreasing temperature. The slope on this one, because elderly people are more vulnerable, is 3% per degree centigrade of cooling increased death rate. So these are substantial effects. Does the 1 mean 1 minute? Okay. This is the most spectacular data set from the United States. This is average daily mortality rate for all-cause mortality. The cause-specific I don't have time to show you. All-cause mortality for 1972 to 1988 as a function of the day of the year. So 0 is January the 1st, this is December the 31st, and this is June, July, and August. This is a spectacular U-shaped, inverted U-shaped curve that shows really, really, really low death rates in the summer and really, really high death rates in the winter. The ratio, depending on what year, what place, whatever, varies from 7 to 10. Anyway, there are 7 to 10 times more deaths due to cold in the winter than there is to heat in the summer, and that's including heat waves. There are strong medical arguments as to why heat deaths are less deadly in the sense of loss of life than cold deaths, but I don't have time for that now. I'm just going to read my conclusions. It's the bottom 3 paragraphs of the executive summary. A cooling of 1 degree centigrade can be projected to lead to 200,000 increased deaths per year in the United States and Europe. This hazard to public health is of the same magnitude as the number of deaths from automobile accidents or the total number of deaths from breast and prostate cancer. Given that natural causes of climate change, such as fluctuations in the solar magnetic fields or multi-decadal oscillations, are of significantly greater magnitude than anthropogenic CO2 causation, there is little that can be done, especially in a cost-effective manner, to prevent climate change, whether it be cooling or warming. Given the sun that is now at its quietest in the past 50 years, for sunspots and for magnetic field strength, there is a significant chance for cooling to reach 1 degree centigrade or more. If world leaders are serious about protecting public health from climate change, they should be discussing methods of adaptation and alleviation of effects of cooling or warming, not economy-killing schemes of carbon taxes or carbon emission limits. Thank you very much.